12.4, probability of compound events. So if A and B are two events, any two events, then the probability of A or B is signaled by the probability of A or B. It's equal to the probability of A plus the probability of B minus the probability that both A and B occur. Okay, so the probability of A plus the probability of B minus the probability of both A and B. If A and B are mutually exclusive, okay, so in other words, A and B can't happen, so like rolling a die or flipping a coin, you can't have more than one event occur. Okay, then the probability of A or B is just equal to the probability of A plus the probability of B. Okay, and we'll talk about that more in this first example. So example 1 says probability of mutually exclusive events. So it says you roll a number cube. So we're rolling a die. What is the probability of rolling a 3 or a 4? Well, I can't roll a 3 and a 4 at the same time with rolling one number cube. So it says let event A be rolling a 3, let event B be rolling a 4. Event A has exactly one outcome, because there's only one way I can roll a 3, and that's if I roll a 3. Event B has exactly one outcome, because there's only one way I can roll a 4. So the probability of A or B occurring in a mutually exclusive event is the probability of A plus the probability of B, which is 1 out of 6, because there's only one way out of 6 that I can roll a 3, plus 1 out of 6 for rolling a 4 is equal to 2 out of 6, or 1 out of 3, which is approximately 0.333. Okay. Now, the probability of a compound event where we don't have mutually exclusive. So in this case, we're rolling a number cube again. Okay. What is the probability of rolling a number less than 4 or an even number? So I need to take into consideration, so rolling a number less than 4. Well, I have three possibilities. I could either roll a 1, a 2, or a 3. Or an even number. Well, my even possibilities are 2, 4, and 6. Now notice that I've got overlap there. I could roll a 2, and that would satisfy both conditions. 2 is less than 4, and 2 is an even number. So let event A be rolling a number less than 4, and let event B be rolling an even number. Event A has 3 outcomes, and event B has 3 outcomes. But of these, one of the outcomes is common to both A and B. So the probability of rolling a number less than 4 or an even number is the probability of A plus the probability of B minus the probability of both A and B occurring. So the probability of A is 3 out of 6 plus the probability of B, which is 3 out of 6, minus the probability of rolling that 2, which is 1 out of 6. So that gives us 3 out of 6 plus 3 out of 6 is 6 out of 6, minus 1 out of 6 is 5 out of 6, which is approximately 0.833. Okay. Now using intersection to find probability, so using groups that intersect. So in a poll of 50 students, 19 were student council members. Okay. 33 played a winter sport. And 48 out of 50 were student council members or played a winter sport. Okay. So what is the probability that a student council member, or what was the probability that a student is a student council member and played a winter sport? Let event A represent being a student council member, and let event B represent playing a winter sport. So from the given information, we know that the probability of being a student council member was 19 out of 50. We know that the probability of being in a winter sport was 33 out of 50. And the probability of being in one or the other is 48 out of 50. Now we know that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so now we're going to substitute in. We know that the probability of A or B was 48 out of 50. We know that the probability of A is 19 out of 50. The probability of B is 33 out of 50. And we're looking for the probability of A and B. So if I adjust this and solve for probability of A and B, which is this right here, so I need to add probability of A and B to both sides, and I need to subtract 48 out of 50 from both sides. So 19 out of 50 plus 33 out of 50 minus 48 out of 50. So 19 plus 33 is 52. 52 minus 48 is 4, so 4 out of 50, which reduces to 2 out of 25, which is equal to 0.08. Okay, and then the last thing we're going to talk about is the probability of the complement of an event. So complement is just the opposite. So if I was saying to roll a 1 on a number cube, I would have a probability of 1 out of 6 because there's only one way that I can roll a 1. And then the probability of not rolling a 1 is rolling any other number. So that would just be 1 minus 1 out of 6 or 5 out of 6. So the way that we find the probability of a complement is we just do 1 minus the probability of the event occurring. Okay? So example 4 says, when two number cubes are tossed, there are 36 outcomes. Find the probability that the sum is not 5. Well, the easiest way to do this is to figure out how do we get a sum of 5. Okay, so first figure out what is the probability of a sum of 5. And so the only way that I can get 5 is with 1 and 4, 2 and 3, 3 and 2, or 4 and 1. Remember, each die is separate, so I've got 4 different ways that I can come up with a sum of 5. So the probability that the sum is not 5 is going to be 1 minus the probability that the sum is 5. So 1 minus the probability of a sum of 5. Well, that would be 1 minus 4 out of 36. So that would be 36 over 36 minus 4 over 36, which would be 32 over 36, which reduces to 8 over 9, which is approximately 0.889.